Okay, here is the answer to the question 2. We know that according to the conditions, the little fx of x is e to the negative x plus 1, and the gx is the magnitude of x. So here we graph the gx. It's like this. This is the graph of gx. So here we want to use fundamental theorem to know what little fy of y looks like. But because this gx isn't continuing, so we have to divide it into two parts. The first one is one axis between -1 and 0. The other one is one axis between 0 and 1. So here, when we separate it into two parts, and then we can use the fundamental theorem, so we can get uh, the format of x is like this: e to the negative x plus 1 plus e to the negative x plus 1. And then we substitute x with y. We can get the format of y. So here is the little fy of y is like this: e to the negative y minus 1 plus e to the y minus 1. This is when y is between 0 and 1. So here we can see when y that is gx is bigger than 1, it's going into infinity. So here we know that little fy of y is 0, and when y is less than 0, it goes into negative infinity. It's also the little fy of y is also 0. So here we need to know what the number is when y is 0. Here we simply integrate it when x from 1 to the infinity. Here we know that it's e to the negative 2. So the format of the little fy of y is like this. And then we can graph it. We can draw it like this. Here is y. Here is little fy of y. When y is 1, little fy of y is e to the negative 2 plus 1. When y is 0, little fy of y is e to the negative 2. And we also want to know what the capital Fy of y looks like. Here we can simply integrate it like this: from y from 0 to y. And then here we omit the steps. We can directly get the answers is like this. So when y is between 0 and 1, we can get that it's negative e to the negative y minus 1 plus e to the y minus 1 plus e to the negative 2. And when y is less than 0, capital Fy of y is 0. When y is bigger than 1, capital Fy of y is 1. So here we can graph the capital Y of y. It looks like this.